Lesson 3.4, Slope-Intercept Form. What we will learn today. To determine the slope and y-intercept of a graph, and to write an equation of a line in slope-intercept form. We have two vocabulary words that apply to this lesson. The first vocabulary is y-intercept. The y-intercept is the y-coordinate of the point where a line crosses the y-axis. So remember that the y-axis in a coordinate plane is a line that's vertical or going up and down. This is the x-axis. So the y-intercept will always be where a line crosses the y-axis. That will be our y-intercept. Slope-intercept form is our second word, a non-proportional linear relationship that can be written in the form y is equal to mx plus b. M represents the slope or our constant. B represents our y-intercept. This is going to be very important to know when we are graphing. For our first example, we are being asked to state the slope and y-intercept of the graph of the equation y equals 2/3 x minus 4. In the previous slide, I showed you that the y-intercept or the slope-intercept form is y is equal to mx plus b. And if you recall, I said that m is slope and b is our y-intercept. I'll abbreviate it with int. So if we're looking at this equation, y equals 2/3 x minus 4, the slope, all we really have to do is go to the ratio or whatever number is right before the x. That's my m or slope. So the slope is going to be 2/3. Keep in mind, that's our rise over run. Our y-intercept is the b or whatever comes at the end of the slope-intercept form equation. Remember that the negative always goes with the number that it comes after or that it's before. So my y-intercept is -4. So I have just stated the slope, which is 2/3, and the y-intercept, which is -4. For example number 2, we are to write an equation of a line in slope-intercept form. So once again, our slope-intercept form is y is equal to mx plus b with a slope of -3. So our m will be -3 and a y-intercept of -4. And all we're going to do here is substitute. We are going to substitute m with -3. So the y stays the same. I'm going to have -3 as my slope. My x stays the same. And then I have my -4, which is my y-intercept. Okay. Now I can write it this way. I can also write it y equals -3x plus -4. In the original equation, the slope-intercept form equation, we have the plus sign in front of the b. So if you want to leave that plus sign, that's okay. Just remember that the y-intercept is -4. So either one of these equations would be correct. Example 3. Write an equation in slope-intercept form for the graph shown. Again, slope-intercept form is y is equal to m times x plus b, where m is our slope and B is our y-intercept. So the y-intercept is very easy to identify. Once again, it's the point on the y-axis where the line intersects. And it's this point right here. And they even tell us that the y-intercept is 4. So that's going to be very simple to identify. So that's going to be 4. And let's put the plus in front of it. The y stays the same. My x is going to stay the same. The slope is what I'm going to have to figure out here. So what I'm going to do to find the slope, just like we did in lesson 3.2, is I'm going to do my rise. So slope is rise over run. I'm going to use m to represent slope here. So if we take 1 unit down, and we know that's -1, and 2 units to the right, or +2. So my slope is -1/2. Let's replace m with -1/2. And now my equation is y is equal to -1/2 x plus 4. Before we move on to the next example, let's talk about interpreting the y-intercept. So what does the y-intercept mean? When an equation in slope-intercept form, so y equals mx plus b, applies to a real-world situation, the slope represents, so again the slope is m, it represents the rate of change. So how something is changing. And the y-intercept represents the initial value or the starting point. Real world examples. Number 4, student council is selling t-shirts during Spirit Week. It costs $20 for the design and $5 to print each shirt. The cost y to print X shirts is given by y is equal to 5x plus 20. You'll notice that that's in slope-intercept form. Graph y is equal to 5x plus 20 using the slope and the y-intercept. So let me draw my quadrant, and I'm only drawing the positive quadrant because I can only have positive values. Here's my x and my y. My x is my amount of t-shirts. My y is my cost. And now write dollars because it's being represented by dollars. So what I'm going to do is I'm going to go up, or I'm going to label my dollars, or my t-shirts, sorry, 1, 2, and so on. And I'm going to label, since I'm starting off at $20, my initial cost is going to start at 20, but I'm still going to go up by 5s because it's going to be going up $5 each t-shirt. So I'll go 5, 10, 15, and so on. Yeah. And so when I'm graphing with the slope-intercept form, my y-intercept is where this graph is going to intersect the y-axis. Again, the y-axis is the vertical line. So that's my initial point, $20. Okay, starting there. And my slope, right now, it's just at 5, but that's pretty much the whole number 5 over 1. So I'm going to be going up $5 over 1 t-shirt. Up $5, 1 t-shirt. Again, each t-shirt is $5. And I graph 5 points. You don't need to graph 5 points. With 3 points, you're good enough. That's what the graph will look like. So again, I use the y-intercept to mark my starting point. Y-intercept is 20. That's where I start. And then my slope, if it's a whole number, I change it into a fraction by making my denominator of 1. So I'm going at $5 for each t-shirt. Example 5 is related to example 4. Now they're asking us to interpret the slope, which my slope was m. M is equal to 5. And my y-intercept. So my y-intercept was 20. So in this case, my slope represented the cost of $5 per t-shirt. My y-intercept represented my initial cost or starting cost of $20. So when we're asked to interpret, that's what it represents. Slope is the $5 per t-shirt. The y-intercept is my initial cost of $20. So let's review a couple of things. We talked today about the slope-intercept form. And that's y is equal to mx plus b. And m is my slope. And b is my y-intercept. Now, why would I need to know these? It's because when I am graphing, the y-intercept is going to tell me where on the y-axis my line will intersect. Let's use that as an example. And the slope is going to tell me whether I'm going up or down and then across. We can use this as an example of a line. Again, my y-intercept, where the line intersects the y-axis. The slope is rise over run.